Let me start our number 10 lectures. And at the end of number 9 lecture, we have solved this problem. And Ajahn mentioned that to solve this problem, we got to know about what so-called moment of a force. And I did put something in the problem, but I would like to invite you to go back to the PowerPoint number 7. On the PowerPoint number 7, we're talking about the moment of a force. The moment of a force in two dimensions we have mentioned already, and it's very simple. The moment in 2D is going to be the force times the moment arm. I said this is going to be what's so called the moment arm. That's going to be the distance measured from the point of the moment to the force. But in 3D, we got to use the vector to do the calculation. Yes. Oh, sorry. And Ajahn didn't much force you about the problem number 4. That's going to be very tough. Anyway, since the university asked me to teach you, so we cannot neglect it. At least we got to touch it. Then for the moment in the form of the vector, we just take the moment vector. This is moment vector equal to position vector cross product with the force vector. Ajahn said this is a kind of cross product. Don't worry, I will mention how to do it. It's going to be in which the position vector must be direct from the point O and to the force F always like this one. Right? I will be talking about it later. And then the moment M sub O will rotate, okay, from R to F, from vector R and then to vector F in this direction. That's going to corresponding to this moment vector. And then what we got to do it, we got to take the right hand and rotate your finger allow this direction to indicate the rotation. Now, you got to use the same concept of the moment arm. This is going to be the moment arm, the distance measured at the point of the moment to the force, the perpendicular distance. And this is going to work since the angle here is going to be theta. So the angle here going to be theta. So if these are, if you put it, you will get the picture something like this one, D dot, and this one is R, and this one is theta. So the D dot is going to be determined equal to R. Cosine going to be here. And then that's going to be R sine theta. The distance over here will be R sine theta. Okay, so basis upon this one, the magnitude of the moment about O going to be R sine theta. Going to be V. Okay, times the force S. And then we got to say that is the perpendicular from the axis of point O to the line of action of the force, as I show you over here. So this is going to be in the unit of force, can be Newton and the distance meter. Sometimes it can be in the form of kilonewton meter. And then following this one is going to rotate in the right hand direction. And then going to be from this one, from R to F. Then this is important from the last problem that Ajahn show you how to do the cross product. Okay, it's going to be in the form of this one. You got again to write the position vector. I should say this is going to be position vector. And F, again, you got to write it in the form of force vector. And from the previous lecture, problem number 4, you must be able to write the force vector. Also, you must be able to write the position vector. When you got it, you just put in the form like this one, the unit vector I, J, K, gonna be on the top. Okay, and the position vector R sub X, I. Just put over here R sub X, I. R sub Y, J. R sub C, K. Okay, and then the force vector F sub X, I. F sub Y, J. F sub C, K. Then do a copy of this one and put it over here. And also do a copy of this one and put it over here. Now you get everything. Let me erase this thing. Now, after you get the format of the cross product in the form like this one, you got to do the multiplication in this direction. You got the first term R sub Y F sub C, R sub Y F sub C, and it is positive. Okay, and then you put it in this direction. That's going to be R sub C F sub Y, but it is negative. Okay, so put it on the downward right hand side. That's positive. On the left, going to be negative. For this second one, you put it again. That's R sub C F sub X. That's going to be the positive. And you put it in another direction. You got R sub X, F sub C. That's going to be negative. And then it's repeat for another one, for the last one. R sub X, F sub Y. This time positive. In another direction, you take this one, R sub Y, F sub X, and it gets negative. In conclusion, when you put to the right, it's positive. When you time it to the left, it's going to be negative. Okay, and then that's going to be the result of the moment of a force. That's going to be in the form of vector. Again, that's going to be in the form of vector. And then we have another thing that we didn't use it yet. It's going to be about the moment, about a specific axis. We're talking about the moment of a force already. That's again is going to be the moment equal to the position vector cos the force vector. The problem is the moment that you determine can compose of the component in the x direction, in the y direction, and in the c direction. If we prefer to rotate the screw over here, the required moment is going to be in this direction. So only M sub C is required to turn the screw. Now, how can we compute it? Go back to what we have. we start with M sub A equal to position vector cos F. And then we have the concept of dot product. Dot product is a kind of projection. We got to determine M sub C. That means we got to project M sub A into C axis. How to do it? We use the dot product. This is going to be the dot product. And the dot product can be on the switching. Okay, so basis upon this one, we may write the moment M sub C. That's required to this the screw here can be computed by putting the specific axis and dot product to the moment vector. Okay. In conclusion, we got to do the calculation. However, the dot product produce what? Produce only the magnitude. Okay. So if you prefer to know the moment vector in that specific axis, you got to take that magnitude and the direction. So you will get it in the form of vector. If not, you will get only the magnitude because the dot product produce only the scalar. Again, how can we compute it? Again, if you prefer to get the magnitude of M sub C, now you put it like this one. R and F going to be the same. R sub X, R sub Y, R sub C. F going to be the same. F sub F, F sub Y, F sub C. However, on the top, that's used to be IJK. Now, you only interested for this one to be only K. So it's going to be 0, 0, and 1. And do the same thing. Okay, just take this one, 0, R sub X, and F sub X, and then 0, and then take the copy, R sub Y, F sub Y. Then you multiply it in this direction. Sorry, you multiply it in this direction. That's 0. Multiply this one in this direction. 0. You multiply this one, so you get R sub X, F sub Y, and it is going to be positive. If you multiply it in this direction, you got minus R sub Y, F sub X. And for this one, 0 and 0. At the end, following this one, you get the result to be this one, R sub X, F sub Y, minus R sub Y, F sub X. Ajahn, that's kind of confusing. Don't worry, okay? I just only teach you, but I can show you, and then later you will comprehend it. And we require to solve. We require moment of force about specific axis to solve some problem. And I will talking about that's really tougher than the previous one. Okay. Okay. And then that's going to be on the lecture number 8. You may download it. It's going to be under the video clips. Okay. This video clips number 10. And then coming to the problem that we have, we're going to again work on the example on our midterm examination. We have the problem in your hand already, right? Okay, let us start to work together from problem 1 to problem 2 to problem 3 and to problem 4. We prefer to have problem 4 first. And then go to 3, go to the 1, 2, and the 1. Which way you like to have? 1 to 4 or 4 to 1? Okay, 1 to 4. Let us start from this one. We have this problem by Ajahn Chao, okay, many years ago. and he keep the pictures over here. Is the cable system. Okay, this is going to be cable system. This cable system composed of four cable. Let me put it in this one DE, and then this one CD, and then CA, and then the last one for the CD. You can see we have the total of four cable. And for sure, I'm gonna ask you to determine all of them. If you scan to the bottom of this one, Ajahn asks you to determine B, C, and A, C, AC will be group A, C, and then for B, E. Okay, that's going to be what you are looking for. How to determine it, Ajahn? Oh, you got to do the step that Ajahn also provide you. You got to draw the free body diagram. You got to formulate the equation of equilibrium. Now, let me take you back. After you read this one, let me modify the problem a bit. Last time, we have the rate, okay, to be unknown. That's going to be the previous lecture. Now, let me assume that we have the mass of the lamp here to be 20 kilogram. So, we have the mass of 20 kilogram. W gonna be equal to the mass time G. Okay, the gravitational acceleration. So this is going to be 20 times 9.81. And you got to get this one to be 196.2 Newton. Since this is the force, so the cable will develop tension. When we're talking about the tension, we're talking about the force that point right out. Okay, or point out. That's going to be the tension or point out of the joint, point out of the particle. Now, imagine about this one. Simple question. Okay, so the joint will be stable in equilibrium. So the force in the light blue and the yellow cable will be developed. And I can suggest you start the free body diagram from the joint that's subjected to the external force. Now, versus upon this one, you will require to bear the reference axis. Okay, and then under application of the force of 196.2 Newton, the force in the cable must be developed. And I can say the force in the cable must along the cable direction. So this is going to be, you may call F sub CD. And there is another one on the cable DE. That's going to be, just copy it, okay, and put it in the same angle, about 30 degrees. So you only copy the pictures, and this is F sub DE. Okay, and the next one, you move to another joint. The whole system of the cable will be in equilibrium if the joint be in equilibrium. So the joint C in equilibrium. So we represent it by the particle C over here. Then you got to put the reference axis again X and Y. And then what do you have? The table series, okay, is in tension. Then the force that at point C must point out also, okay, is going to be in this direction, the same magnitude with the opposite direction. That's going to be F sub C B. Then when we push it, imagine when we push it, the green and the orange must helping each other to resist the light blue force. Then follow what we have over here. Just make a copy. Okay, this is the green. So just put in power direction. That's going to be the force F sub A C. And then you will notice that they provide the proportion over here to be 3, 4, and 5. Then you have the force F sub A C. You have another one, CB. Just make a copy. This is going to be F sub CB. F sub CB have 45 degree here. So in opposite direction, this is going to be 45 degree. Okay, you got 2 points. Okay, only now the pictures, you got 2 points. Then we got to formulate the equation, and you got to start from what? You got to start from this one. And then they want you particle C and particle D. Actually, it's better to start from the joint. Okay, that this joint, the particle D is subjected to the extra force on the weight, extra weight tip of the lamp. So we got to start from this one. Then following this one, you may see this is going to be the component of F sub BE. And since it's 30 degree, F sub, oh, sorry, they put it in T. Okay, let me just change all of this to T. All the T. Just change it to T. Change it to T. Assign it to be T. Okay. Now, we got it corresponding to this one in the T. Let me start from particle D. Since particle D is subjected to the external weight, 192 Newton. And this is going to be P sub BE. And close to the angle, that's going to be 30 cosine 30 degree. And then we put it in this another direction. This is going to be P sub DE. You use cosine already. It's going to be sine 30 degree. And you can see in this horizontal force, there are 2 unknowns. Okay, we will not start with this one. See, over here, there are 2 unknowns. We will start in the y direction. Let me start first over here. In the y direction, what you guys have? This is T sub DE sine T sub DE and sine 30 degree. You put this one upward, okay, to be positive. Then you have this negative minus 196 0.2, and then is equal to 0. Actually, you may rewrite it again. T sub DE gonna be equal to 196.2, and then divided by sine 30 degree. Put the number into your calculator. T sub DE gonna be 392.4 Newton. Okay, you may check. Okay, then when you get the U sub DE, this is equal to 392.4 Newton. You go next to step 2. For the summation of x sub x equal to 0. Now, you're looking for P sub CD. You have CD. So, put the direction to be positive and T sub CD in the horizontal direction positive. This one going to be negative. So minus T sub DE 392.4 cosine 30 degree and put it equal to 0. It's not tough, not that tough, very easy, right? So you got to take it and get them high. So P sub CD is gonna be equal to 392.4 cosine 30 degree. And you should get this one equal to 339.83 Newton. Wow! You have T sub CD already. Okay, so put it on that 339.8 Newton on T sub DE. Oh, you get 392.4. You have two force already, see? Then after you know the force T sub CD, just put it over here, T sub CD. So it's going to be 339.83 Newton. Now, you know the force here. Then you should be able to determine T sub AC and T sub CD. Again, you do that. Determine the component of this one. This is going to be T sub AC. In the vertical, this one, in the vertical, this is going to be 4 over 5. So it's going to be 4 over 5. And then you have another component in the horizontal. That's going to be T. So T sub AC 3 over 5. And also, if you do the projection of this one, this is going to be T sub CD. And that's going to be sine 45 degree. And if you project again on this one, you got to have T sub CD. And then cosine 45 degree. Now, which one you got to start first? If you put it in the horizontal, you have 3 forces. But if you put it in the vertical, in the y-axis, you have only 2 forces. I prefer to go by the y. Okay, let's put it in this one, step number 3. And then this one is upward. So put the upward to be positive. And then you have what? T sub AC times 4 over 5 upward. And this one is downward. Minus T sub CD sine 45 degree. And then that's going to be 0. Okay, just do the simplify of this equation. Let me put it to be T sub AC equal to, take this one to the right. That's going to be T sub CB sine 45 degree. And then you have 4 over 5. It's going to be 5 over 4. Take, actually, you need to zero. It's going to be equal. Okay, and then take 5 times 4. Then you have what? This is going to be T sub AC 0.8838, and you get this one T sub BC or CB going to be the same. Okay, you didn't solve it, but the equation now is going to be simple. Then going to the first step, okay, we got to do the summation of x sub x equal to 0. Put the direction of the unknown to be positive. You have T sub CB cosine 45 degree, and then plus T sub AC times 3 over 5, and then you have the minus 339.83, and then put it to be 0. Now you have T sub AC to be equal to this one. Take this one, put it over here. If you put it over here, you will get this one to be T sub CB cosine 45 degree. And then over here, you have plus 0.88388, and then T sub BC. This is going to be T sub AC, and then 3 over 5. That's going to be 3 over 5, and then put it equal to move it to the right. 339.83. Now you can do the combination of this one. You have T sub VC in the same form. Okay, so you see in the same form. So you may like it. T sub CB or BC is going to be okay. T sub BC cosine 45 degree plus 0.6 times 0.8838, and then closes, and then equal to 339.83. Now your T sub BC gonna be the combination of this one, 339.83, and then divided by. Okay, and then put all together. You should get this one to be 1.23743, and then finally you get T sub BC equal to 274.6 Newton. That's going to be your T sub BC, 274.6 Newton. Then you take this one, T sub BC, keep here, okay, over here. So your T sub AB gonna equal to 0.88388, and then times to 74.6. Put it in your calculator. Your T sub A B sub A B A AC your T sub AC gonna be equal to to 42.7 Newton. Did you get the same number as I get? Okay, that is 272.7 Newton. That's not tough, see? You get the total of 8 points already. And you can see basis upon the result that you get. This T sub DE is maximum. This sub DE is maximum. Okay. When you increase the load, the T sub DE will get larger and larger. Okay. If the mass is increases, okay, continuously, okay. If you increase the mass continuously, okay, DE, table DE will be fail first. When DE fail, the whole system collapse. Okay, if the DE fail or separate into two pieces, the whole thing falls down. Okay, so the next question, determine the maximum mass of the lamp that the cable system can support so that no single wire or cable, okay, so that no single level of attention exists. Let me change it to 4,000. How to do it? From the basic of this one, this is going to fail first, okay, and then we will say, okay, 392.4, okay, the tension occur due to the mass of 20 kilonewton. If you say the tension increased to 4,000 Newton, so the mass going to be equal to 20 times 4,000 and then divided by 392.4. So the mass maximum is going to be equal to 203.87 kilogram. That's going to be the answer for another 2 points. Let's check your engine sense, okay, to know the difference between the forces in each cable. They are not the same, okay, the same mass, 20 kilonewton. Produce the force in DE 392.4 Newton, and this is the largest force. Then when we increase the mass, this one still get the largest force, and we reach 4,000 Newton first, and it's third. The concept will be like that, and then just do the proportion. Okay, you will get the answer easily. Can you get the 10 points from this one? I believe so. If you tying, but if you don't tying, that's going to be tough. Everyone can help you. Only you can help yourself. Okay. Any question of this one? Compare the difference between this one and the previous one. Previous lecture. The previous lecture, everything just W Remember, they didn't provide the mass to you. Actually, on this problem, also, Ajahn didn't provide the mass to you, I just modified it. That means Ajahn Chao, he love to design this kind of problem. Okay? Now, if you have no question, let me move since we have the video to record our lecture. Let us move to the next one. And Ajahn also, like you guys get 10 points. Another problem by Professor Vacharapum. He is now talking about the balloon. We got the balloon festival on our farm, okay, last week, right? Okay, that's going to be nice to have it. Let's take a look at the balloon. The three cable, the three cable. You may say, cable AB, cable AC, and cable AD. Don't confuse with this one. This one is not cable. Okay, so actually, Ajahn should say for cable AB, cable AC, and you also should have the cable AD. Used to hold the balloon in equilibrium. Now, if the balloon in equilibrium, this joint A can represent the whole system of the balloon. If joint A will move, the balloon will move, the cable will move. The problem is said this is a special condition. They didn't ask us to determine the force in the cable AC. They just said AC has 444 Newton. And they asked us to determine the vertical force P, okay, exert to the balloon at A, and the also forces. What going to be? Versus on this one is mean that the balloon gonna lift up. Okay, when you're trying to lift up, but three cable helping to hold each other. That's going to be cable A B. Okay, cable A B, cable A B, and for the cable AC, Ajahn provide you with the force, and that's going to be the force in this yellow cable. However, Ajahn asks you to determine the lifting force P. Okay, and then you got to draw the free body diagram, and Ajahn asks you to do that with 3 points. The concept of drawing the free body diagram again is the concept of copy. Okay, copy everything. Copy everything. Just take the ruler, and if you prefer, take this one. If you put it 10 centimeter, it's going to be about here. Even the letter, put it in a same position. Put it in the same position, please. Just put it close to the child. Then for 10 centimeter, you get another point of this point O. Put the A here. Okay, and then you have this is the end of C. Keep over here, and this is going to be positive C axis, and this is going to be C axis, and then for the X, just put it here again. The arrow must be in this direction because this is going to be positive X. The garage. Okay, And then for the y, it's going to be up, like this one. Follow the given coordinate because we got to determine coordinate. Okay, we got to follow the x, y, z axis. Okay, since we got to determine coordinate, join A, B, C, D. So keeping X, Y, C noted. Then there are the support that hold the balloon. Let me start by the point C. This is going to be point C. Okay. And this is going to be the point B. If you want to teach it, it's going to be hard to the pictures. And then noted the point B is on the C axis, but in the negative C. So just put it over here, 10 centimeter, and this is going to be the point D dot. Okay. Now, putting the load at the first of T. Okay. This is going to be the force of the balloon trying to lift everything up. And then we're going to have the force over here, A, B. It's going to be the tension. The tension force always point out, okay, point out from A to B. And that's going to be P sub A, B, from A to B. And then we have another one, A to C. We may draw this one over here. This is going to be the force P sub A, C. And also the other one, you have A, B. This is going to be the force of P sub A, D. Okay. Not finished yet. This is 3 points. Okay. Not a copy. Okay. Come back and helping me to determine the coordinate. Now, A is the origin. O is the origin. So, the coordinate x is 0. X gonna be 0. Y gonna be 0. C gonna be 0. Okay. And then, what's going to be the coordinate of A? Okay, come. What is the coordinate of A? Helping me to determine it. What's going to be the coordinate of A? Just put yourself under the balloon. Clamp it over here. Okay. It's going to be in the y-axis. You clamp it forward. For 5.6. So it's going to be x going to be 0. Y going to be 5.6. And C going to be 0. It's on the y-axis. Then come to the B. Again, B is on x-axis also. Okay. E is on x-axis also. This is going to be minus x. This is minus x. Take yourself. Walk along the line over here. Okay. You're going to be on the negative x. So you walk forward. See my finger. You walk forward. You walk it from here. You walk it. You walk by 4.2 meter in the negative. Right? So you got to have this one to be minus 4.2 x direction. And then 0 because it's on the x-axis. And also 0 because it's only on the x-axis. Okay. Now, you move to point C. Trying to walk from X to Y to C. Okay, coming to this one, this is X. You walk along the X. Okay, you walk along X by what? By 2.4. And then you turn, you make a turn, and then you walk along this one. Going to be what? 4.2. So on the X, you walk by 2.4. So this is 2.4. And this is going to be on the C. Okay, C axis. And that's going to be 4.2. So X is going to be 2.4. Y is going to be 0. And C is going to be 4.2. That's going to be point C. Now, the last one. You just walk along this line. This is in minus C. How many meters you walk? How many? How many? How many meters you walk? 3.3 in the negative C. Okay, so you have X equal to 0, Y equal to 0, and negative C minus 3.3. This for 3 point. You got to draw a good free body diagram. Now, follow what we have here. You got to go to right. As I mentioned from the start of the lecture on the PowerPoint, to determine anything, you got to write the force vector. After force vector, you will write for the moment vector. So write the vector of the forces. Okay, we have any force. The easiest one gonna be P. Okay, P is the lift. Okay, it's the lifting force. Lifting force. Upward in which direction? In the y direction. So we have the first one, vector P equal to magnitude, and then the direction. Okay, we have only Pj. Then you know the T sub AC. You have the magnitude of this one to be 4 Newton. So T sub AC. Let me move it up. T sub AC. Then equal to the magnitude times the direction. We put the direction in the form of unit vector. Okay, this is going to be the direction in the form of unit vector. Okay, to determine the unit vector, we got to know about the position vector. Okay, so you got what? AC. Position vector from what? From A to C. And then you got to divide it to determine the unit vector by the magnitude. Okay. Now, what's going to be sub AC? Again, as sub AC from A to C, you use the coordinate of what? Of AC. Use the of C, and then minus the coordinate of A. Okay, AC. Put the C minus the A. Then we have this one, 2.4 minus 0. 2.4 minus 0 I. Okay, 2.4 minus 0 I. and then what? Plus 0, 0 minus 5.6, 0 minus 5.6. Okay. Okay. Put the head first. Then plus, then 4.3 minus 0. So 4.2 minus 0, and then K. Now, you have the position vector R sub AC equal to 2.4 I minus 5.6 J, and then plus 4.2 K in unit of meter, and then the magnitude of it. What going to be magnitude? R sub AC, the magnitude going to be square root of 2.4 square minus 5.6 square plus 4.2 square. Just put everything together. What did you get? 7.4 meter. Then we have this one equal to 4, 4, 4. Okay, 4, 4, 4. And then time. That's going to be 2.4 I minus 5.6 J, and then plus 4.2 K. Then just divide it by 7.2. Okay. Now you put it slowly. T sub AC gonna be equal to, just take this one. Okay. Oh, 7.4. That's good to see. 7.4. Okay. Thank you very much. But you have what? You have 4, 4, 4. And then times 2.4 divided by 7.4. And then I. Okay. And then minus again 4, 4, 4. And then 5.6 divided by 7.4 J. Do something with this one. And then you have what? The last one. Plus 4, 4, 4 times 4.2 divided by 7.4. And then K. Okay. In the final, you put everything together. It's going to be the first one. 1, 4, 4 I, and then minus 3, 3, 6 J, and then plus the last one 252 K. Okay, and that's going to be in unit of Newton, and the magnitude of this one going to be 444. Okay, so we have two vectors. Okay, the first vector is going to be P. Okay, the second vector P sub A C gonna be the yellow. Now we move to the green. Okay, we move to the green. For the green, we have P. The green T sub A B. T sub A B. This is going to be T sub A B. It's going to be the magnitude. Okay. And then the direction. And then for the direction of this one is going to be what's the vector? A to B. Sub A B. Position vector divided by its magnitude. Now, what's going to be sub AB? It's going to be AB. B minus A. So if you like, you should put it like this one. Okay, or just in short, B minus A. And then what you get? That's going to be B minus A. Don't forget that. Equal to minus 4.2 and then minus 0 I. Then 0 minus 5.6 K. And then the last one plus 0 minus 0 and then K. Okay, so R sub A B. Position vector going to be minus 4.2 I. Right? And then minus 5.6 J. And then the magnitude topic R sub AB equal to square root 4.2 square plus 5.6 square. Okay. What did you get? 7.0. 7.0. Okay. We have this one to be 7.0 meter. Then coming into this one, we have T sub A B. And then on top, we have only two terms, minus 4.2 I minus 5.6 J. And then just divide by 7. Okay. And then we have this one just extend it. It's going to be minus 4.2 divided by 7T sub AB I minus 5.6 divided by 7 T sub A, B, and J. Okay. In short, we will put it is going to be equal to T sub A, B minus this one 0.6 T sub A, B, I. And another one, this one, minus 0.8 T sub A, B, J. That's going to be our green, okay, tension force vector. And now we have only one left. That's going to be the orange. Okay, that's going to be the orange. For the orange, we have T sub A, B. No, this is A, B. Sorry. This is A, D dot. Coming to the last one, T sub A, D. T sub A, D vector equal to magnitude times the position vector R sub A, D. Position vector R sub A, D divided by the magnitude. Now, what's going to be R sub A, D? Again, equal to A, D, equal to coordinate of B minus coordinate of A. Take note on this. Don't write this one. No, don't write this one in your examination. Okay, I just show you in order to help you understand it better. Some ajahn may confuse. What is that? Okay, so it's gonna be put together B minus. Okay, so 0 minus 0 I. Then 0 minus 5.6 and then J and then plus 3.3 minus 0 K. So we have this one to be minus 5.6 K. And then another one minus 3.3 K. Okay, that's going to be position vector A, D. What's going to be the magnitude compute? Okay, that's going to be R sub AD equal to square root 5.6 square and 3.3 square. 6.5. You got 6.5 meter. Now, coming over here, we have T sub AD and then minus 5.6 J minus 3.3 K divided by 6.5 and meter by meter cut. We have this one. Okay. What did you get? You will get the term as before. Minus 5.6 divided by 6.5 T sub AD J and then minus 3.3 divided by 6.5 T sub AD K. Okay. And then just extend it. You will get T sub AD equal to minus 0.862 J. The first one. T sub A B. This is the first term. And then another term minus 0.508 T sub AD and then K. Okay, we have the orange force over here. All the force. What's going to be important? You can move now. You don't need free diagram. Okay. The third, the equation of equilibrium. Equations of equilibrium in vector form. Okay. In the vector form, how many force do you have? We have how many force do we have? So go back to the free body diagram. You have what? You have this one, T, and then plus T sub AB, and then plus T sub AC, and then plus T sub AD. That's going to be 0. Okay. Actually, this is going to be summation of the force vector equal to. Now, you got to identify the component compute. Okay. This one will combine into summation of x sub x equal to 0. Now, we just take this one. Summation of f sub y equal to 0 and summation of f sub c equal to 0. We got to check for each one. First, summation of x sub x equal to 0. You got to check for the I. What the component of the three forces that have the I? See, you have this one for the I. You have this one for the I. And that's it. Okay, you have no more. So, for this one, you have 144 and then minus 0.6 T sub AB and then is equal to 0. Just take the component of the I. Then T sub AB gonna be 144 and then divided by 0.6. You get the first answer. T sub AB equal to 240 Newton to 40.0 Newton. Then you may move again. You don't need to have the free body diagram. You just to check the force vector or the vector of the force. Then going to the second one, summation of the y equal to 0. Taking for the j. This is the j, the j, the j, and the j. You have total 4 components. So just put it. Okay. This is gonna be P. And then this is minus 3, 3, 6. And then this is minus 0.8 T sub A B. And then you have this one minus 0.862 T sub AB. You have total of 4 terms. Then this is going to be equal to 0. Now, you may put T sub AB over here. Okay. But you don't get the solution yet. Go to the next one. Summation of F sub C equal to 0. Taking for the component of the C, of the Z. Okay, you call it. This is component of the Z. This is going to be the component of the Z. This is positive. This is negative. You have plus 252 minus 0.508 T sub A D, then equal to 0. You like it. T sub A D equal to 252 divided by 0.508. Okay. And then what you get, just put it in your calculator. That's going to be 496.1 Newton. Huh. You get the second one already. Now, you got T sub AD. Okay. So, therefore, P, your P. Take this one to the right. 3, 3, 6, and plus 0.8 times T sub AB. And then minus 0.862. And then you get 496.1. Okay. Put everything together. You get the force P. Okay. To be 955.6 Newton. That's going to be the lifting force of the balloon. Okay. This will go to the far. Last week, I did. I have the picture with the octopus. The whole octopus is very cute, in my opinion. Then, put it. That's 955. That's 955.6 Newton. That's going to be 3 point. And T sub AD, that's going to be 496.1 Newton. And T sub AD, that's going to be 240 Newton. That's it. Is that tough? I don't think so. I think you can solve it. This is going to be 20 points. That's enough to get close to the grade of C. Okay. We have two more problems to try to solve it. Okay. But again, I still love you to trying to go back home, solve it by yourself. Again. Okay. And make sure you comprehend what Ajahn tissue